Problem number 3. How many ordered pairs of positive integers will satisfy this equation? Alright, and we've got y is equal to 18 over x. And again, we've got positive integers, just like in the first problem of this set. And now you know what positive integers are. So let's take a look at this. My hint to you would be to multiply both sides by x. Okay? And then x over x just becomes 1. And we have x times y is equal to 18. So, think of a different way to word this question. We're asked how many pairs, ordered pairs, of positive integers. So ordered pairs, and it looks like the xy. Okay, so ordered pairs xy. So if you think about a different way to word this question, once you multiply both sides by x, we're looking for x times y, where x and y are positive integers, and that has to equal 18. So this is really just asking what are the how many factors are there of 18, because factors come in pairs, and if they're ordered, then the number of pairs will just be the number of factors. So that's not too bad then. So go ahead and if you haven't worked this problem yet, go ahead and work some more on it. And I'm going to go ahead and give you the solution. So we're asked to find the ordered pairs x and y that multiply to 18. So we're just looking for the factors of 18. Factors of 18. Okay. Now, it's really not too bad to list all the factors of 18 and count them. We can do that pretty easily. We have 1 and 18. We have 2 and 9. We'd have 3 and 6. And it looks like that's it, right? So how many ordered pairs can we make? Well, we'd have 1 and 18, right? But 18 and 1 is different in this case because they're asking for ordered pairs. Okay. So we also have 2 and 9, but then we also have 9 and 2. Okay, because order matters in this case. And again, we'd have 3 and 6 and 6 and 3. So we could just count them. 6, right? We have 6 ordered pairs that we can make. Now there's actually a quicker way to count factors. And let me show you that way, because sometimes you have a bigger number. 18 is pretty easy to deal with, but if you have bigger numbers, sometimes it's a lot of work to list out all the factors, and it's really easy to miss factors. So let's take a look at this problem as a counting problem. So 18, let's figure out what the prime factorization of 18 is. We know that it's 2 times 9, and 9 is 3 times 3. So the prime factorization of 18 is 2 times 3 squared. Okay? So we have 1 2 and 2 3's. And in order to figure out what the factors are of 18, whatever the factors are, they have to be some combination of a power of 2 and a power of 3. Now, the power on either one of these can be 0. So the power on 2 could be 0, or it could be 1, right? Because this is essentially 2 to the 1. Okay? So you can choose, so essentially you have 2 choices for the power on 2. And the power on 3 could be 3 to the 0, that should be 1, 3 to the 1, which is 3, or 3 squared. Alright? So you can think of it as we have two choices for the power on 3 and two choices for the power on 2 and 3 choices for the power on 3. So 2 times 3 is equal to 6. So that's a quicker way of counting factors. It's just it's the power on or the exponent on each of the prime numbers in the prime factorization plus 1, and then multiplied by each other. And we can look at that in a little more detail if we list it out. So if we're trying to make factors of 18, let's start by choosing the powers of 2, okay? And we can either choose 0 or we can choose 1, okay? And then let's choose the exponent on the factor on let's choose the exponent on 3, and we can choose that to be 0 or 1 or 2. And if we choose, that's for the power on, if the power on 2 is 0, then the power on 3 can be 0, 1, or 2. And if the power on the exponent on 2 is 1, again, the exponent on 3 can be 0 or 1 or 2. Okay? So that gives us all the combinations. 2 to the 0 times 3 to the 0 gives you just 1. 2 to the 0 and 3 to the 1 is 3. 2 to the 0, 3 squared, that's 9. 2 to the 1, 3 to the 0, that gives you 2. 2 to the 1 and 3 to the 1 gives you 6. And 2 to the 1 and 3 squared gives you 18. Okay, so we get the same 6 factors that we had, before, when we figured it out before. Okay, all 6. Oops. Okay, those are the same as these 6 factors. All right, we just figured them out in more of a counting way. All right, so so that's another way to figure it out. So if we have a number, I'm not going to calculate this out, but what if we had like 2 to the 4th times 3 squared times 5 to the 3rd? Okay, I don't know what that number is. I'm not going to calculate it, but so how would we figure out how many factors that number would have? Well, we'd have 5 choices for the power for the exponent on 2, right? It could be 0, 1, 2, 3, or 4. So 5 choices for the exponent on 2. We'd have 3 choices for the exponent on 3, right? 0, 1, and 2. And we would have 4 choices for the exponent on 5, which would be 0, 1, 2, or 3. Okay? And what is that? As we got 20 times 3, that's 60. So for this number, we would have 60 choices. Now you wouldn't want it if you had, we'd have 60 factors. Now, to try and list out all those factors would be hard to do. But we can still count the factors this way, and it's a lot easier. So this is a good tool to have. And our answer is 6. We have 6 ordered pairs of positive integers that satisfy this equation.